Okay, so when we talk about deep learning, a lot of people think about, smarter chatbots or something like that. But that's not the real story here. Not for us, anyway. For engineers, the real power of deep learning is something way bigger. It's about automating solutions to problems we used to think were, well, impossible. Today, we're going to dive into how deep learning isn't just another fancy tool. It's basically becoming the ultimate engineer itself.
So let me just throw this question out there, and it's going to sound a little bit like science fiction, but stick with me. What if AI could actually design itself? I mean, really think about that for a second. This isn't just some hypothetical for a philosophy class. It's happening right now, and it's pretty much the key to unlocking the entire next generation of artificial intelligence.
And that question leads us straight into what you could call the architect's dilemma. See, for the longest time, designing a neural network was, well, it was a huge pain. It honestly felt more like being an artist than an engineer. A whole lot of intuition, a ton of trial and error. It was this massive bottleneck that just slowed everything down for years. So, what's the engineering fix for this dilemma? It's something called neural architecture search, or NAS for short. The easiest way to think about it is, it's like a master algorithm that completely takes over the design job. So instead of a human architect trying to guess the best structure, NAS just goes out and explores this huge universe of potential designs to find the absolute best one for whatever you need it to do.
And when you put the two side by side, the difference is it's night and day. The old way, the manual way, super slow, really expensive, and you're always limited by what a human can think up. But NAS, it's a total game changer. It's fast, it opens up the field to way more developers, and honestly, here's the most amazing part. It often comes up with these totally new architectures that are more efficient than anything a person would have ever thought of on their own.
Okay, so how does it actually work? Well, imagine this giant tournament, but for AI designs. In the first round, thousands of different potential designs all submit their blueprints. Then, each one gets put to the test on a real-world problem. Only the ones that do well move on to the next round, get a little bit better, and compete again. This just keeps happening over and over, with the designs constantly evolving until you're left with one clear winner, the absolute best architecture for the job.
All right, so that's pretty incredible, right? We've got deep learning automating the design of AI itself. That's a huge cognitive task right off our plates. Now let's take that same core idea, automating a complex problem, and apply it to a totally different world, secure communication. What if you could send a message so secretly that nobody even knew you sent one? Well, welcome to the fascinating world of steganography.
You know, steganography is like the ultimate magic trick for data security. We all know about encryption, right? That just scrambles a message. It's still there for everyone to see, it's just messy. But steganography, it makes the message itself completely vanish. It hides the very fact that a message even exists inside some other ordinary file. Like imagine hiding the secret blueprint for a new processor inside the tiny audio fluctuations of a birdsong file. That's the level of power we're talking about here.
Now, the old-school methods of steganography had a problem. They were often kind of easy to spot if you knew what to look for. But, you guessed it, this is where deep learning completely changes the game. I mean, the source material says it perfectly. Deep learning models can automatically figure out these incredibly complex and subtle ways to hide data, and then pull it back out again.
And the impact here is just huge. First off, security goes way up. You can use these things called adversarial networks, which basically train one AI to hide the data and another AI to try and find it. They play this constant cat-and-mouse game until the hiding AI gets so good it's almost impossible to detect. Plus, you can stuff more secret data into a file without messing up the visual quality. And maybe most importantly for us, the whole thing is automated. The AI finds the perfect hiding spots all on its own, with superhuman precision.
Okay, let's shift gears one more time. We've talked about designing AI, we've talked about hiding messages. Now let's go to a field where the stakes are, well, about as high as they get, human health. Because modern medicine is generating an insane amount of data, and it's created a challenge that is just perfectly suited for the automating power of deep learning.
And seriously, it's not just a lot of data. It's a data tsunami. You've got MRIs, entire genomic sequences, complex patient records. It's just this overwhelming flood of information. And we know the clues to preventing and curing diseases are buried in there somewhere. But for a human to find them, it's like trying to find one specific grain of sand on every beach on Earth combined. It's impossible. And this is where deep learning can be, quite literally, a lifesaver.
And, no surprise here, the solution is automation through deep learning.
You take something like a convolutional neural network, which is basically a super-powered pattern-finding machine. It can look at thousands of medical scans or sift through mountains of genomic data and spot these tiny patterns or anomalies that are completely invisible to a human doctor. But those little patterns, they can be the critical signal that tells you what's really going on.
The impact in the real world is already happening, and it's profound. We're talking about true precision diagnosis, like classifying a cancer not just by where it is in the body, but by its exact molecular signature to get a truly personal treatment. It's speeding up how we discover new drugs because it can predict how complex proteins will fold and interact. And it's making healthcare more accessible. You can have an algorithm providing top-tier diagnostic help in a tiny clinic hundreds of miles from the nearest big hospital.
So let's just take a step back for a second. Designing AI, hiding secret messages, decoding human health. On the surface, these seem like three totally unrelated engineering challenges, right? But they're all being solved, they're all being pushed into the next frontier by the exact same powerful core idea.
The common thread here is automation. But we're not talking about automating a factory assembly line. We are talking about automating complex cognitive tasks, the kind of stuff that used to take a human expert years and years to master. This is what deep learning is really all about. It's becoming the fundamental engine of digitalization, shifting the whole paradigm from humans manually crafting solutions to systems that can learn to find solutions all on their own.
So really, the big question isn't just what can deep learning do? We're seeing what it can do. The real question is, what are you going to do with it? As the next generation of engineers, you're being handed a tool that can automate the impossible. So think about it. What's that big, complex, messy problem, the one everyone thinks is unsolvable, that you're going to choose to solve?